Hey everyone, in today's lesson we are going to look at raising a power to another power. So this is building on from our previous lesson on multiplying and dividing with indices. So our learning intention for today is that we can understand and apply the power of a power index rule to questions involving algebraic terms as well as questions involving just numbers. So if we consider the expression 4 squared all to the power of 3, so if we're looking at this expression here, you can see what this index of 3 means is that we have 3 of the value 4 to the power of 2. And if we expanded this out, we would get 4 squared times 4 squared times 4 squared. So we have the 3 4 to the power of 2 there. Using our previous rule of multiplying indices, we can do 2 plus 2 plus 2, and we get our value of 6. So as we did previously, let's look at what the relationship is between the two powers that we originally started with and what our answer has. So what's the relationship between 2 and 3 that's going to give us 6? Well, obviously, we can multiply 2 and 3, and that will give us the value of 6. So the index rule for power of a power is when the power is inside the brackets, what we need to do is we need to multiply the powers together. So if we have a to the m all to the power of n, then what that means is we have got a m times n, and if it's algebraic, we would write that as a mn. So let's look at what this looks like when we are doing some examples. So if we have got 5 squared all to the power of 4, then that's simply 5 to the power of 2 times 4. So we'll get 5 to the power of 8. Now, it doesn't matter if we're using pronumerals. As before, we can do exactly the same thing. So if we've got a to the power of 4, all to the power of 3, what that means is we have got a 4 times 3, and we get a to the power of 12. Now, when we have a pronumeral attached to our terms inside the brackets, what we need to be aware of is this squared not only affects the 5 that we've got here, but it's going to affect the power of the 1 that's on the 4. So when we are multiplying using the power of the power rule when we've got more than one term inside the brackets, or the term that has a coefficient, what we need to do is we need to apply it to both terms. So we've got that 4 to the power of 1, and we're going to times that by 2. And then we have b to the power of 5, and we're going to times that by 2 as well. So we end up with 4 squared b to the power of 10. And we know that 4 squared is 16, so we can replace that with 16 b to the power of 10. Now, we can see here we have an interesting thing where we have minus 1, or minus m. So what that means is we actually have inside the brackets minus 1 times m. And that's what's going to give us this term here of minus m. So we have got all of this to the power of 4, which means we have, as before, minus 1 to the power of 4 times m to the power of 4. And as with before, we can work out what this minus 1 to the power of 4 is. So what we have here is minus 1 times minus 1 times minus 1 times minus 1. And that's all going to be to the power of 4 in the end there. But what I wanted to focus on was this first part here, where we've got minus 1 times minus 1 times minus 1. Now, we know that two minuses make a positive, and here we have another positive. So what we actually have here is 1 times 1, m to the power of 4, which means we have m to the power of 4. And what I wanted to focus on for a minute was just this situation that happens where we have a negative number and we are multiplying by an even power. So we've got an even power attached to a negative number. Now we know that two negatives, so we know that two negatives make a positive. So when we have an even term, we know that there's always going to be two of every one of those negative values. So whenever we have a positive term, the answer, if it was negative, is going to become positive. And similarly, if we look at the next question where we've got minus 2b 3 to the power of 3, then we are again going to have minus 2 to the power of 3 b 3 times 3, which gives us minus 2 cubed b to the power of 9. And let's look at this term here again of the minus 2 to the power of 3. And what we find is we have got minus 2 times minus 2 times minus 2, and then we've got the b to the power of 9. So again, let's focus on this part here. And what we have is minus 2 times minus 2, so we have positive 4 times minus 2 b to the power of 9, which leaves us with negative 8 b to the power of 9. And as before, what we are seeing is when we have an odd power, which is attached to a negative, as we have here, then our final term is going to remain negative. So if we wanted to just highlight that, when looking at signs, an even power makes a negative positive, and an odd power leaves a negative negative. So there are two quick ways that we can work through those without having to do this expanded form here. So as an example, if we had minus 6 b to the power of 4, then what we have is an even term, so that's equivalent to 6 to the power of 4 b to the power of 4. And expanding 6 to the power of 4 out, what we would have is an answer of 1296 b to the power of 4. So what I'd like you to do now is have a go at the exercises that have been set, and remember, if you have any questions, contact your teacher.